Very good morning to all. Today this session is about the advanced data analytics for research. Okay, I am here Dr. B. Lakshmi Praveena, Professor CSEAML, PVRIT Hyderabad College of Engineering for Women, Hyderabad. So welcome you all for our session Advanced Data Analytics for Research. In this session, we are going to cover with the introduction to data analytics, summary of statistics, and we are covering with the probability and model building and data visualization and performance evaluation and advanced data analytics tools. Okay. So here first we will enter into the introduction to data analytics. So first we will go through the what is actually the data analytics it is. So data analytics is basically the purpose of a data analytics is to gather the hidden insights of the data. That is, say for example, I am taking some information or some data. Okay, from that data, if I want to extract some hidden information, okay, that is each and every information will not be present within the data. So some information we need to be gather and we need to be get the information from that existing information. And next is the generate the reports. So using this we can visualize the information. So for this we need to check with the what type of audience are there for the information and what type of information we need to be present, and at the same time we need to check with the what type of visualization is to be used. So next is the data analytics are required for the market analysis or to find out trends or to find out demand and to find out what type of products are in the present market. Okay, these all we can find out with the help of this data analysis. At the same time we can also find out business requirements with the data analytics. So using the data analysis we can find out the requirements of the business, and based on that we can improve the requirements. So before going into the data analytics, first we will understand what actually the meaning of a data analytics it is. So data analytics is especially to analyze the data and also to improve the productivity and also to improve the sales and also to improve the business growth and to improve the organizational growth. So these all we can achieve with the help of data analytics. Data analytics is basically of two parts. So one is with the business administration and second one is with the exploratory data analysis. So with the business administration, that is whoever are participating in the administration of a business, okay, they need to take a proper decisions to improve the business and to sustain within the market. So for that they will go for the data analysis tools. So using this data analysis they will be find out different information of the current market and current trend and current situation of the society. So based on that they can improve their business, they can take a better decisions in the business, and so that it will be improved. So who is actually the data analyst it is, and the role of the data analyst. So the data analyst main role is first is collecting of a data. So once the data analyst collects the data, okay, the data may be either structured data or maybe the unstructured data. So if it is a structured data, they will be stored within the MySQL or any RDBMS databases. If it is unstructured data like a text data or any different combinations of the data, then they can use the NoSQL databases. So once the data is collected and once the data is stored, the next step is for analyzation of a data. So for this analyzation of a data, the user can use the different types of analytics tools and different types of analyses they can perform on the data, so that once after getting the information from this analysis part, so then the user can create the reports. So that is to visualize the information. So next further in the data analysis, just we will go into the different types of data analysis methods and what is actually the data analysis it is, that we will understand from now. So data analysis is actually defined like a process of different steps. Okay, the different steps includes with the cleaning and transforming of a data and modeling of a data. So for cleaning of a data is required for So generally whenever we are collecting a data, we don't expect that the data would be in our required format. Data would be with our all required values, and data would be with all related values. So sometimes we may have the different dimensions of the values, and sometimes we may have the most of the values are not present in that, and sometimes we may have the values of which are not related to that particular column or particular domain. So in that cases we need to go further the cleaning of a data, that is to fill the missing values and to remove the unrelated data and to format the data into our required format. And the next step is called as a transforming. So here we need to transform the data into our required format. Okay, why it is required is generally we will collect the information from the different sources. Some information you will be collect as a text information, some information you will be collect from the clinical data, or some information you will be collect from the social media. So these all information are in the different formats, are in the different structures. So all this need to be converted into the one particular format, then only we can work with that data. So the transforming is converting our data into our common format. So next part is the modeling of a data. So here the modeling of a data is by applying the different models of the data analysis, we can extract the information, we can understand the information, and we can find out remaining different useful informations. Okay. So the main purpose of a data analysis is especially to find out a hidden information and also to find out a useful information from the data, and based on this useful information and based on this hidden information, the decisions can be taken taken by the different types of a higher management. So next is the different types of a data analysis methods. So the major data analysis methods are like text analysis, so where we will analyze the given plain text or some social media reviews or social media comments, or we can also go for Facebook comments or Facebook posts, Twitter posts, LinkedIn posts. Okay, these all comes into the text analysis. Next is a statistical analysis, where we will apply the different types of statistical methods to understand the data and to explore the data. And next is the diagnostic analysis, where we will apply our analysis methods to test the data. So that is whether our data is working properly or not, whether our data is based on our requirement or not, whether the data is providing all the information required for my purpose or not. Okay, these all we can do with the help of a diagnostic analysis. So next is a predictive analytics, where we can find out a future data or future information based on the existing information or based on the historical information. So next is a prescriptive analysis, so where we can take up, that is based on the analysis, we can give the different types of suggestions and different types of precautions we can suggest, so that the next whatever the goal they want to reach, okay, that can be achieved with the help of this prescriptive analysis. So next we will see the one by one these analysis methods. So one of the analysis method is a descriptive analytics. Okay, so generally the analysis is whenever we are making an analysis of a data, so we will get the information in the form of a numeric format. But actually whenever we want to give it as a result, whenever we want to give it as a conclusion, so we need to be convert the data in the form of a sentence. So that analytics is called as a descriptive analytics. Say for example, I am getting a result as a 90%. So then I need to be represent it as the current analysis result is a 90%. So there is a possibility to increase it, or this is based on the previous analysis methods. So this type of analytics is called as a descriptive analytics, and which will be useful for the key performance indications. Okay, and this is also makes us a strategy for the different types of decisions and different types of success and failures. Whenever we want to give the analysis result, we can give it as a success, that is 100% success, 90% success, 70% success, and we can also give it as a something like ROI values. Okay, and here we will use some different types of metrics to find out performance information and to find out different information for the different industries. Okay, so here we will process the data and we will get analysis results, and we need to represent the data as a data visualization and as a reports. Okay, next is the diagnostic analytics. So where the diagnostic analytics is like so we want to go for the testing of a data. Okay, that is say for example I want to find out some information, and I want to know that whether that information is available with that data or not. So then I will make a questions to the data. Okay, what is the highest salary from the, that is say for example I have the employee data. Okay, I want to test the data, then I can ask the some questions like, so what is the highest salary of the particular department, or I can ask for the, so what is the role which is having a highest number of people, and what is the department where the employees are more, and where the two departments which has with the same salary with the same designation. So like this I can make a different types of questions with the data, say, and I can find out a different information. Okay, so from the this descriptive analytics we can find out the findings are something like we can find out the anomalies within the data, and at the same time we can find out the related data which is producing these anomalies. Okay, and we also check that the different statistical methods which are used to find the relationship between the data. Okay, so these all we can find out with the help of diagnostic analytics, so that whenever you are testing the data, then you can find out what type of dependencies can be occurred within the data. That is, say if you are requesting for, that is you are trying to retrieve the data of a salary, say if it is affecting the some other data like a department data or designation data, if it is affecting it, then we can say that there is an anomaly. So like updation anomaly, or some insertion anomalies, or maybe some deletion anomalies. And next is the predictive analytics. So where this predictive analytics is like whenever we want to give the future data from the existing data, so then we will go for the predictive analytics. So here the predictive analytics is like so we can ask the some questions which will give the data like future, in future. That is, say for example you are saying that in the previous week, say if I studied for the 2 hours every day, so that I got a 70% of a result within my exams. And if I want to get a 90% of a result, then what will be my plan? Okay, then based on the your given data, like every day you are spending of a 2 hours, so that you got the 70%. So whenever you are taking a future data, you can be predict like, so with this 2 hours of a preparation you got the 70%. If you are increase the 2 hours into the 2.5 hours preparation, then you may get the 90% of a result. So like this we can predict the information based on the existing information. Okay. So for this we can use a different types of statistical methods, we can use a different types of machine learning methods, and we can use a different types of neural networks, decision trees, and regression methods. Next is the prescriptive analytics. So where the prescriptive analytics is especially used to what we need to actually do for achieving of our roles, our goals. Okay. So using this prescriptive analytics, we can also achieve the predictive analytics. At the same time, we can go for the particular decisions. Okay, say for example, you are saying that in the similarly like in the predictive analytics. So in the last week, if I prepared for 2 hours, I got the 70%. So that you can give a prescription like, if you are preparing for 2.5 hours within the next week, so you can achieve your goal of a 90%. That is, you are not predicting the value, but you are showing the way or path, or you are giving suggestions to get the goal. Okay. So this is especially used, the prescriptive analytics is especially used for the to take a better decisions and to follow the different types of paths for achieving of that goal. Okay. So this is also based on the analyzing of past decisions or past events. Okay. And the different methods of the data analysis are the cluster analysis, cohort analysis, regression analysis, factor analysis, and neural networks, and text analysis, and data mining methods. Okay, these are the different types of essential types for the data analysis. Okay, so I will go into the one by one. First, we will check with the cluster analysis. So, cluster analysis is like whenever we are making an analyzation of a data. So, first thing is we will check for whether the already existing data is classified into particular conditions or not. If it is not classified, then we will go for the cluster analysis. That is, if the data is already not grouped, if the data is already not decided for the particular decisions, okay, then for taking of decisions, we will make the data into the groups. Okay, so this groups must be in the related format. Okay, whenever the one related information or similar information is grouped into the one particular set, then we can call it as the cluster analysis. Similarly, like say for example, I want to take a different types of actions or different types of plans I want to make for my students based on their based on their result. Generally, what we will do is we will make a three groups as a slow learners, medium learners, and bright learners. Okay, so based on their performance in the exam, we will do these type of groups. So for slow learners, I can give the easy questions, and for medium learners, I can give the some hard questions, and for bright learners, you can give the challenging questions. Okay, so that you can analyze them or you can improve their understanding power to make into the more clever. Okay, and next is the cohort analysis. So this type of analysis method is especially based on the historical data, and this will compare the different types of segments of users behaviors. Okay, like I want to find out analysis of my sales, like last year sales in the different months. Say for example, you are comparing with the January sales and you are comparing with the February sales, and you find out that January sales is higher than that of the February sales. Then what we will be think is the February there is a very less festivals, so that the sales is very less, and January has the more festivals, so that more sales is there. So then what we will do is we will make a comparison of these two, and we will take a decision if like so February sales is less, so that we can give the more discounts in the February. Okay, so for that this cohort analysis is used. That is, you can compare the different segments of your historical data, and based on that you can take some decisions. Okay, at the same time, this cohort analysis is also used to find out customer needs, and also used to find out the customer behavior, and also used to find out the impact of your campaignings or marketing. Okay, especially this cohort analysis is used within the marketing purpose. Next is the regression analysis. So where the regression analysis is especially for prediction purpose. So we have the one target variable that is already predicted value, and we also have the independent variables. Okay, so based on this independent variables and existing predicted value, we can test the new data, and we can find out new predicted values. Okay, so based on the existing predicted values, we can find out new predicted values for the new data, so that which gives us the flexibility to find out new information at the same time. So based on the existing information, we can predict the new information also. Okay, and next is the neural networks. So where the neural networks is especially for whenever you want to reduce the manual intervention, and whenever you want to process the different type of structured information, like different types of different structures information, where the normal analysis methods are not fit. Okay, then we can go for the neural networks. So here it is like say for example, I have a text video information, I have the image information, and I want to find out what is the emotion analysis of the data of image, or whenever you want to find out the sentiment analysis of the video information. Okay, then in that cases we can use the neural networks, and we can find out our required information from that. Okay. Next is the factor analysis. So here this factor analysis is especially used for the dimensionality reduction. So where say for example I have the 30 columns of a data and 1 lakh records. Okay, then actually for my analysis, if I didn't require all the 30 columns, then I can find out a correlation between the variables and correlation between the attributes and features. So based on that, I can omit the sum of features, and I can consider the required features and mostly affected features, mostly impacted features, and based on that we can do our analysis part. Okay. So next is the data mining. Okay, this is the one of the important part. So where all the analysis comes into the data mining part. That is, before going for the analysis, the basic step that is to be done is the collecting of information, converting that information into a required format, and then analyzing of a data. So this data mining can also be called as this is umbrella for different other techniques and different other data analysis methods. So in using this data mining, we can find out raw information, and from that we can extract the required useful information by pre-processing the information and others. And next is using a data mining, we can consider the data and how to use that data and how to analyze the data and what actually the information we want to get from the data. So those all also we can check with the data mining, and we can go further with the analysis of a data. Next is the text analysis. So where we will consider the text type of information like paragraph information or simple text like one line text, or we can consider them. So based on the existing text information, we can recommend the new text possibilities or new pattern possibilities. Okay, so that is also comes into the text analysis part. That is recommendation of the words and getting a sentiment or opinion from the text. Okay, these all comes into the text analysis part. And the different types of data analysis techniques. The different types of data analysis techniques comes into the cleaning of a data and setting up your KPIs, that is knowledge points, and useless data you can omit, and we can do the data management, and we can integrate the different types of technologies for the data analysis, and we can answer the different types of questions based on the data analysis. We can visualize the data for getting of a better understanding of a data, and we can interpret the data. So based on the different types of data, we can make an interpretation of a data and build a narrative from the data. That is, you can build a story from the data. At the same time, we can make different types of autonomous technologies we can use and share the load. That is, without doing all the work by the one single person. So the analysis tools can share the data, can share the load, and different types of data analysis tools are used to make these all steps. So next we will get into the summary of statistics. That is, up to now we covered with the introduction part of our analytics. Okay, the different types of analysis methods and different types of tools we can use, and different types of impacts of the data analysis. Those all we checked in the up to now, and now we'll get into the summary of statistics. So whenever we are going into the data analytics part, okay, first we need to know the data. That is, we need to understand the data. So what actually the data is talking to us, and what actually the data is saying information. So that we need to find out. So for this data understanding, so we will use the statistics. Okay. So within the statistics, one of the statistics is called as a descriptive statistics. So where we can use the descriptive statistics to provide the descriptions of the data. That is, either we can do the numerical calculations, or we can do the different types of graphs and tables, and we can represent the data in the different visualization formats. So using that we can understand the data. Okay, that is, say for example, here the picture is showing us there are the different types of blocks with the red color and black color. Whenever we are making a descriptive statistics, we will categorize the data into the two different parts. Okay, so based on the understanding of a data and based on the knowing of a characteristics of the data, we can make them into the two different groups. Okay, so that we will be find out that what is a volume of a data in the different categories, that we can know with the this type of a categorization of a descriptive statistics. Okay, so in different categories of a descriptive statistics are one is like a measure of a center and measures of a spread. So one is a measure of a center is, so based on the center point or based on the center value of a data, so you can find out what are the neighbors with that center value. Okay, say for example, I want to make a groups of the students based on the performance. I will be take a center value for the slow learner as a, say for example, out of a 1 to 40 marks, I want to take a center value as I say 20 marks. So around the 20, whoever the students are there, then I can consider those all as the slow learners. And for the medium learners, I can take a 50 marks as a center point, and around to that 50 marks, whatever the students are there in that 50 marks surrounding, those all can be considered as a medium learners. In the similar way, like a bright learners, say if I am taking a 75 as a center point, so surrounding to the 75, whoever the students are there, those all can be considered as a bright learners. So based on the one particular point as a center point, you can consider the whatever the neighbors are there to the center point, those all can be considered into the one particular block or one particular group. Okay. Next, descriptive analytics, we will be check with the measure of a center. This we can find out with the help of a mean or median. So mean is we can find out our average value, and based on that we can fix the center point. Median is based on the center values average, we can find out a median value. Okay, say if it is the number of the values are the odd values, then we can directly find out a center value. If the values are even values, then we can take a middle two values and we can get a average. Another thing which we can use to find out a center is the mode. So based on the different values which are repeatedly used within my data, so based on that we can find out a center value. So the given example is showing us this 25 is the mostly frequently repeated value, so that we can consider the 25 as the mode of a data. Next, in the descriptive statistics, measures of a spread is based on the range. That is the range of a data which we have within the data set. Okay, like minimum value and maximum value. Based on that, we can find out a range of the data. At the same time, we can find out the interquartile range. The quartiles are like something we can call it as the 25% is a first quartile, and 50% is a second quartile, and 75% as the third quartile. And minimum is considered as a 0 quartile, and max is considered as the 100% quartile. So this quartile ranges we can find out, and based on that we can know the information how much of information is there in this each quartile range. So next, based on the variance, we can know how the information is spread. That is the difference between the different values. And standard deviation, say for example, if you are considering the one of the line as a center line, and from that center line or center point, how much of each value is deviated. So whether it is deviated into the positive or in the negative. So based on that, you can find out how many number of values are deviated from the actual requirement. That we can find out with the standard deviation. And the different other types of categories of statistics is, one is the inferential statistics. So this inferential statistics is like whenever we are analyzing with a large data set, and whenever we are working with a large data set, then we will check with the probability to get a conclusion of our data, and to get a conclusion of a decision. Okay, so like say for example I have some data items like black boxes and red boxes. Using a inferential statistics, so we can make some flow like that is we will start with some step and process the data, and then we will get into the decision, and based on the decision we will go into the particular answer. That is say for example if I am taking this data set, the example data set, I can take a one by one box and I can check whether it is a red or black. If it is a red, I can make into the one particular bin. If it is a black, I can place it into the another bin. So based on this we can categorize the data. And similarly like hypothesis testing, so where we will make a hypothesis for our analysis, that is whatever the actually the objectives of the our analysis is there, that we will take it as the hypothesis, and finally we'll test that whether our data is satisfying that hypothesis or not. Okay. We can also know that whether the hypothesis is to be accepted or rejected. Okay. So the state of hypothesis is very important while analyzing of a and while testing of a data. Next, this is the comparison between the descriptive and inferential statistics. Okay, whenever we are considering the descriptive statistics, there is a we'll have the different properties of a population, and inferential statistics is which checks with the sample, and descriptive statistics is with the meaningful manner, and inferential statistics with the future outcomes. And descriptive is with can be represented as a charts, tables and graphs, and inferential statistics is represented as a probability score, and descriptive is specifies about the known data, and inferential with the unknown data, and descriptive with the by measuring of a center point and spread of a data, and inferential is by hypothesis and analysis of variance. And how we can find out a variance of a data, that is whenever we are going into the analytics part, we also need to know that what different analyses we can do, and how we can do that analysis part. Okay, so that we also need to know that what is a variance and what is a deviation, and what is the actually the different types of analysis parts we can do. Okay. So variance is generally called as the observations are called as a x, and the length of observations is the n, that is number of observations. So whenever we have the observations and we have the count of observations, then we can take a, so the each and every observation is subtracted from the median, the mean or median of the observations, and the square value and summation of all that differences will be called as the variance. The example of a variance is something like this. I have a data of a 0367. So for that I can use the variance formula, and I can find out a variance value. So the variance value which we got from here is the 7.5. So that we can say that there is a variance between my data points is the 7.5. Okay. Next is the standard deviation. So where we will find out the square root of a variance is called as a standard deviation. So based on this we can know that how much of a deviation is there in the values. Another one is the confidence estimates via bootstrapping. So bootstrapping is generally called as the method which is used to make a changing of a samples. That is say for example if I have a data set of 100 records and I want to make a testing of my model on this data set, without taking every time the one sample of a data, it will be change the samples. That is, say for example for one time if you are taking a 20 records as a sample, the next time we will be add that 20 records into the existing data set, and we will take a randomly will take another 20 records as the sample. Okay. So using this bootstrapping methods, we have the flexibility to understand the data and flexibility to find out different types of accuracy values from our data. And next is the covariance and interpretation of a data. So covariance can be called as so we will be take our independent variables and our dependent variables. So for those values we will be subtract from the median value, and then we will find out the differences of the our predicted values and our independent variables differences from the mean value, so that we can understand the covariance, so that we need to know that how the our independent variables are dependent to get the predicted value. Say if there is a more covariance is there, then we can say that the more of our independent variables are depending on the dependent variables, or the dependent variables is more dependent on the our independent variables, so that we can find out with the help of a covariance. Next we will go with the probability. So probability is the whenever we are doing the analytics part, so we need to understand the statistics. Based on the statistics we can understand the data, and based on the probability we can know that what is the chances to get achieve the goal. That is, statistics gives us the how that is what part of a thing you can achieve with the statistics, and probability is so what is the percentage of achieving of a goal. Okay, that we can know with the help of a probability. Okay, so using this probability we can understand our information. So here we have a sum of a example of a say there is a set of events is called as A, which is a subset of our real numbers. A is a set of numbers of a real. So from that we are taking up all the probabilities. That is a combination of a probability, that is P of a A1 union A2 A3. The combination which becomes as the combination of all the individual probabilities combination is also to be matched. Say if the overall probability is 100%, then individual probability also makes the also to be become as 100% whenever you added the individual probabilities. So next is the interpretations of the probability. This interpretations of the probability we can generally do with the help of a frequentist, subjectivist and realist. Okay. So frequentist is based on the generalizations of the facts, and subjectivist is based on the subject beliefs or the understanding of the subject, and finding of a relationals between the relationship between the data, and based on the outcomes of the data. Okay. And realistic is we can know the random world, or randomly we can find out information from the real problems of the data. Okay. Next is the probability distributions as the samples. Okay. So whenever we are making a sampling of a data, so we need to be follow the some conditions. Based on that only we can find out our samples. Okay. So from the large set of a data, if I want to find out a particular set of data as a sample, that sample selection is also makes our model accuracy. Okay, decides the model accuracy. So for that we need to take a care of while taking a sample of data. Okay. Say for example, there is a one method is called as a flip and draw. So flip and draw is say if I have a dice and I am flipping a dice, and whenever I flip the dice I have a heads, and or I can have a chance of getting a tails. Say if there is a head is a chance is the 0.5, there is a 50% of a chance is there to get the heads, and there is also the 50% of chance to get the heads, tails. Okay. And joint probability of a distributions is say for example I have the 50% of a distribution is there, for probability is there for the particular event. At the same time the another 50% is there for the second event. Okay. So here the example is given as heads and tails for the black and white. Okay. So whenever I use the black dice, okay, then there is a possibility of a 50% possibility is there for getting of are heads, and 50% of a possibility is there to get the tails. At the same time, for the white is also similarly like zero point 0.5 into 0.8, that is out of a 8, there is a possibility of a 0.5 for the each. So then there is a 0.4 is a possibility, and for getting of a white and tails, so there is a probability of a like a 0.6. Okay, so here I have the 0.5 is the number of heads and tails, that is head and tail, there is two values, so 0.5, and 0.6 is like a 60%. Okay, so we'll have the probability is 0.3. Okay, next is the marginal distributions. So marginal distributions is like whenever we are finding of a distributions, so there is a some marginal value which will be used as the error value, or can be called as the difference value between the our required value and the predicted value. Okay, so that value will call it as the marginal value. Okay, so here also the marginal value for the heads is the 0.5 and tails is the 0.5. At the same time, the marginal value for the black is the 0.3 and white is the 0.7. And conditional probability, here the conditional probability is like based on the particular condition or based on the particular criteria, we can say that this much of a probability is there for the particular data. Okay, say for example the probability of a blacks on heads, that is the condition on heads. Okay, that is will get the black based of the condition of a on heads. Okay, so then we can find out that probability based on the probability of a black and heads, that is the combination of a black and head, okay, divided by the probability of a heads. Okay, the total probability of a heads and the probability of a black as the head, okay, conditioned on head. Okay, then the values is like 0.1 for the probability of a black on heads, and probability of a heads is the 0.5, the totally will get the 0.2. And Bayes rule, so Bayes rule is especially like similar to the conditioned probability, the Bayes rule would be there. Say if I want to find out the probability of a B on A, that is conditioned on A, then we need to have a values of like prior information, that is P of B on A is called as a posterior information. P of that is probability of A on B is called as a prior. That is previously you are getting a value based on the condition on B, so that probability, and you also substitute the individual probabilities of the B and individual probability of A. So based on this we will find out how much of a probability is there to get the B on based on the condition on A. Okay, next is the random variables. So random variables is like whenever we are getting of the discrete information, or whenever we are getting of a continuous information, so then we will take a random values. So from the continuous information or discrete information we can find out some random value, so which cannot be like a sequential or which cannot be like a adjacent value, so that we can consider the random values. Okay, so this is especially used for the distribution of a summary statistics, and notation of these random variables is something like P of x equals to x, that is here this is the x is the test data. So this test data I want to find out, I want to know the probability of a test data based on the existing probability, that is this x is the random data, and for that data I want to find out a probability based on my existing data. The sum of examples of the random variables. Okay, so I want to find out different probabilities like heads and tails, and I want to find out the probabilities of like heads and heads, heads and tails, tails and heads, and tails and tails. Okay, so for that all we can find out the information based on the existing data. And next one is the cumulative distribution and probability mass. Okay, discrete random values. Okay, so here one of the method is called as a binomial distribution. So using this binomial distribution we can find out our cumulative distribution value. Okay, so for that you can use the discrete random variable as the x and cumulative distribution function as the fx. Okay, for finding of a x value, okay, with the function of a fx of x, then we'll take a probability of p on x is less than or equals to x value. So where we will find out a sum of all the probabilities of the x equals to x. That is where I want to find out a less than probability. So for that I need to find out all the summation of the probabilities with the x equals to x. Okay, this is also continuation to the previous one. Okay, here also we are using the probability mass function is the p of x on x equals to x. So using this we can find out the probability of that particular x value. And expected value of a random variable, okay, this we can find out with the help of either if it is a discrete value, then we can use it as ex equals to summation of x. So x into fx of x. That is we will be making a product of the x with the function on the x, the function result of the x. If it is a continuous value, then we will make a integration of our data. So integration of x into fx on x. So this here we are using a information is like mean of the representative sample. Okay, based on that sample information x, we are making our discrete value or continuous value. And to find out a variance of the random value, so here we can use the variance methods as the ex minus x whole square and fx of x. That is, here ex is the our expected value, and using that expected value we can make a difference of the expected value with the x, and that products of the values and function on the x makes our variance. Okay. Next is the composite random values. So here using the z, x and y, that is the combination of a different variables. Okay, using that combination of a different variables, we can find out our variances, and we can find out our standard deviations and other expected values. Next we will go into the model building. So up to now we had checked with the two topics. One is the summary statistics and another one is the probability. So using these two we can understand the data, we can know the what is the possibility of achieving of the our analytics or our goal. Okay. So next we will see that how we can build the model and how we can achieve our required results. So here in the model building, okay, there are the different types of models within the statistical models, and we also have the different types of other models like neural networks models, classification models, clustering models are there. So just we will cover with the statistical models. Okay, here the statistical model is like okay, will be called it as the formal representation of the data with the statistical model. Okay, generally we'll use a normal conventional practices for the formalization and for achieving of the model and for execution of the model. Okay. And the definition of our statistical model is like it is like a random process where we will generate the data. So the generation of a data consists of, first we'll make the data into the partitions like D IV and D DV. So is a subset of actual data, and next we will apply the function, likelihood function we will call it as, which will be applied on our partitions. And next is we'll find out if there is any prior information, then we'll use the prior information as the PM of a theta, and based on that prior information we can find out the probability of a D on the theta. Okay. And within this part of the statistical models, one of the model is called as a binomial model. So where we will have the theta as the beta value and k is called as a binomial value. That is, k is the result of the theta on n. That is, n is your existing value and theta is your function. So using that theta and n value, you can find out our predicted value, so which is a k. Next is the flip and draw model. So where we will have the theta is the beta value, and f is the Bernoulli function, and d is the categorical data. That is based on the theta and based on the Bernoulli function. So we can categorize the our data into the particular classification or particular group. Next is a flip and draw for the geometric conditions, hypergeometric conditions. So where we will have the one theta value, that is a beta value, and Bernoulli function is the f. And here there are the two more possibilities is like k and n. That is, there are the multiple possibilities are there. So based on these multiple possibilities and the predicted value of the f, we can get into the one common solution is the k. Next is the t-test model. So where we will use the our gi is the our function, and mu naught and mu 1 are the our mean values or median values, and using all these we can find out our predicted value, that is the yi. So based on this, yi is the predicted value for the observation I. That is, for the ith observation we are finding our predicted value. Okay. So mu naught is called as the initial value, and mu 1 is called as the next value of a initial value. Okay. So next here it is the t-test model with the difference between the means. Okay, say if I have the different values for the different means, like mu naught is a different, and mu 1 is the different, and mu 2 is the difference. There is a different mean values are there. Okay, then we can use this with the different mean values model. So where we will use the normal of a mu comma deviation, that is rho is the standard deviation. So using this we can find out our required t-test model value. Next is a simple linear regression model. Okay, this is also called as the straight line model also. So using this simple linear regression model, will be have the xi is the our input values, and beta naught and beta 1 are the coefficient values. So using this coefficient values and by applying on the our input value, so we can find out our predicted value. So for that we generally use the function as beta naught plus beta 1 xi. Okay, this is especially for like one input value and one target variable, then we can use this type of a linear regression model. Say if the linear regression model, if we want to apply for the multiple input values or multiple independent variables, so then we can use this type of a method where we will have the xi is the particular value and gi is the another value, which is for the similar independent variable. So using that we can find out our required predicted value. Next we will get into the data visualization. That is once after applying of a models and once after your understanding of a data and others. So then next step is you need to visualize the data in a proper format. So for that we will check what are the different visualization methods we can use. So in this visualization methods we have the different types of charts and different types of graphs will be there. So using that we can visualize the data. So some of our visualization methods, the visualization tools are the, so bar graph is the one type of a graph where we will have the two column of information. Two column is like, but we can have the two or more columns of information, then we can represent with the help of a bar graph. And scatter plot is we can identify the density of the each and every information based on the scatter plot. And pie chart is especially for the one column information where we have the pie chart to know the percentage or distribution of the data. And box plot is especially to display the quantile information, like the range information of the data. So here we can find out a minimum, maximum and 3 quantiles information. And line graph shows the comparison of a data, and at the same time the 2 column data can be used with the line graph. So where we can know the progress, whether it is in the increasing or whether it is in the decreasing form. And basic visualization methods or basic visualization graphs are like this. Histogram is generally used to know the frequency of a data, and bar and line chart for the 2 column or more than 2 column data. Box plot is for the quantile information. Scatter plot is especially for whenever you want to know the density of information or whenever you want to know the spread of the information, then we can use the scatter plots. And other advanced visualizations is one is a heat map, where we can know the correlation or covariance of the features. And mosaic map, okay, this we can find out the area or up and downs of your data. Map visualization, where you are showing the locations of the different places, there we can use the map visualization. And 3D graphs, where we want to know the depth of your data, or where you want to know the spread of a data, then you can use the 3D graphs. Another one is a correlogram. And these are the different types of examples for the histograms. Okay, first graph is, it is showing depths and frequency. That is, what are the different depth parts in the different frequencies, like 10 to 30, how much of a frequency of a depth is there, 30 to 50 and 50 to 70. That is within that range of a value. So whatever the depths are there, those all will be shown in terms of a frequency. Similarly, set two colors, where we have the depths and frequency. Okay, another one is the depths and frequency with the different colors, and another one with the 8 colors, and another one with the gray color, and another one with the only green color. These are the different types of histogram graphs. So this is the some example sample code for generating of a histogram. Okay, so whenever you want to generate the histogram using a R language, that is our application, then you can use different types of parameters into that. So there is a method is called as the hist, and for that the first parameter is the our attributes, and second parameter is the frequency, whether you want to show the frequency or whether you want to hide the frequency. Next is the main label, x-axis label, y-axis label, and what type of a range of a data you want to take, whether it is a 0 to 1 or any other. Another one is the column values, that is column names, that is a sky blue and chocolate color. Okay, so using this we can generate the graph. At the same time, if you want to draw the one more graph on that, then you can use the another graph as the lines graph. So where it shows the density value, and where it gives the LWD value, and column as the red, color as the red. And bar and line charts, okay, where we can draw the line chart for showing of a progress, and bar chart to show our existing value. Okay, this is sample line graph, and bar chart, this is a sample bar chart. So where we can represent our different attribute values as the bars, where it gives us the difference between the different attributes, difference between the different attribute values. At the same time, it gives that which attribute is showing a more impact than the other, and which attribute is mostly covered within the analytics part. Okay, this is the example for the box plot. Okay, where we can have the two lines, two horizontal lines represents the minimum and maximum, and dotted line gives us the connection between our min and max and quantiles. And within the quantile box, there is a thick black color line is there, which specifies that the median value, and upper value as the 25% quartile, and lower value as the 75% quartile. And next is the estimates, okay, where we can have the range of a data, and we also find out best values within the data. You are making estimates from your data. Okay, so for this estimates, generally we'll use a Bayesian methods for estimates. So for best value, say for example you want to estimate the best value, then you will be take a mean of the posterior values, and if it is a frequentist value, we'll take a maximum value. Say if you want to find out the interval range, okay, you want to estimate the interval range, then generally we'll take a, using a Bayesian method, you can take a credible interval value, and using a frequentist you can take a confidence interval value. So next, the final and final step of our making of an analysis part is our performance evaluation. Okay, there we need to check with the different types of metrics for the performance evaluation, and comparison of the different models. Based on that, we can estimate the model performance. Okay. So here also the examples of models. Based on these different types of models, we can build the model, and then we can go for the comparison. At the same time, the t-test model is also used to make a comparison of the model by testing of our model data and by testing of our predicted and existing values. And using a hypothesis testing and parameter values also, we can check the performance of the models. So using this estimation and using the prediction and using the comparison, we can test the model. Okay. And Bayesian rule is also can be used to for the parameter estimations and for comparison of the models. So here also we'll use the posterior data we'll get from the with the help of our existing data, that is prior data. So using this prior data, we can find out the posterior, and so that we can check with the whether the existing data and predicted data is the same or not. If it is the same, we can say that the model is 100% accurate. If it is the difference, then we can say that the model is less accurate. Okay. So remarks based on the notation of the information. So here the Bayes rule is basically with the different notations are like probability of a theta on D. Here you are checking that the theta value based on the condition on the D, and P of probability of a D on theta is like a likelihood value or prior value. So here you are finding you are getting an existing value of a D based on the condition on theta value. An example binomial example Bayes rule is like you can use a binomial method to find out a k value, and you can use a beta method to find out a theta value. And these are the some of prior values. So where the prior value can be objective value or can be a strongly informative value, uninformative value, weakly informative value. That is your prior information which is already available, that may be categorized into the any of these different types. And likelihood value, that is your prior value. So the likelihood value may be a king of France or maybe a 24/5. Okay, based on this we can also know the how the your existing values are. And posterior value or the predicted value, the predicted objective, predicted information, or predictive uninformative or weakly informative. Based on the predicted value, we can know that what type of actually the decision is to be taken. Okay, this is one of the example for this Bayes model. Okay. And posterior mean and map values. Okay, so the mean value is like we can take the average value of the existing the new predicted values. So for that you can use the integration of a theta and probability of a theta on D, and posterior maximum value as we can use for the map. So maximum of probability of a theta on D can be called as the map value. And credible interval. Okay, so here we can find out what is the interval between the mean value and max values, and at the same time between the quartile ranges you can find out the interval value. So the difference value between the different quartiles. Okay. And parameter estimation using a Bayes rule. Okay, here we can use the existing data is a fast and easy, and the new data is not actually the reachable. and not actually to be find out. Another one is congruency. Okay. So using that conjugate prior values, so we are not able to get our proper decisions. Okay. And conjugate values of beta and binomial values. So here the claim is actually like beta and binomial are conjugate. That is, you are saying that these two are the conjugate values. Then the proof would be like probability of a theta on k. Okay. So using a binomial and beta values, you can find out a probability of a theta on the k in an n number of samples. And sequential updating in the beta binomial model. So like initially I have the values is the a equals to 1 and b equals to 1. So whenever we are making a sequential updation of a value of a b, so that will be get into the different directions you can see in the values. Okay, so that we will be find out the model performance based on the updation of the our beta values. Okay, and sequential updation in the general form, that is based on the probability values, updation of our values and finding of a probabilities. We can know that how the value is changing based on the updation of the different values. And this is a maximum likelihood estimation and confidence interval value. So based on this confidence interval value, we can find out how the observations are working and how the observations are dependent on each other. Okay. So here the y is our predicted value, and we can find out a percentage of a predicted value based on the y by 100. And here the x1 xl value is the lower value, xu is the upper bound value. So in between that, whatever the true values are there, okay, those we are checking with the help of a confidence interval value. And based on the algorithmic confidence interval value, okay, here the parameter values are the theta 1, theta 2 and theta 3, and our data is the, so each theta will have the some range of values like d11 to the some value, theta 2 is from the d21 to the some values, and theta 3 is the d31 to some values. Okay, so here the interval will be estimated based on the function which is applied on that, and based on that we need to find out a confidence in the interval values. Okay. And this is the algorithm for the confidence interval value. And whenever we want to find out a point valued on the hypothesis, okay, then we can find out what is the practical equivalence of the value and the region of the our required accuracy value. So based on that we can find out our hypothesis value, and based on that we can accept the hypothesis or we can reject the hypothesis. So here is this is also based on the ROPE value. We can either reject or withhold the judgment. Okay, this is the example for this Bayesian model. Okay, frequentist and Bayes model. And Bayesian versus frequentist estimates. Okay, so out of these two, both are based on the prior value, but Bayesian is mostly depends on the prior values, and frequentist is based on the present values. Okay. So next we will go for the advanced tools within the data analytics. Okay, this is the advanced analytics tools. So here actually the data analytics is with the process of a collection and refining and storing and analyzing and presenting of a data. For this we have the different tools for each and every step. How can we collect the data? Actually, we can collect the data as unstructured data or DBMS data. So for that, generally we'll use the REST APIs, that is based on the API methods, API functions. So we can collect the data, and from the end users you can collect the data. That is by taking of a question and questionnaires with the end users, you can collect the data. And web scraping, like there is a lot of web information is there, and from that you can scrap the data and you can take your required information from the web, and you can use the emails or cloud storages. From there also we can collect the information, and from the client servers we can collect the information, that is client systems. Okay, this is the different advanced methods to collect the information. Next, for REST APIs, we will make a HTTP request with the REST API. That is, here we will specify the authentications, and based on that authentications and based on the specified methods, we can take a response in the different types of forms. So general response form is like JSON format or HTML format. So based on that, we can get the data from the different methods. Okay, and we also have another part of executing of this REST API, and this is also used for scrapping of our data. For that, we can use the SOOP, the SOOP tool, and we can scrape our existing documents, existing HTML documents. So for cleaning of our data, especially we'll follow the different type of cleaning methods, like removing of duplicates, validating of existing data, handling of missing data, and fixing of errors, and filtering of outliers. So for storing of data, generally we'll use RDBMS and ORM databases. Okay. And this is one of the library within the Python. The library is called as the pandas. So using this library, we can extract the information, and we can represent the information as a form of a tabular structure. Like say for example, I have a data of like a vector based data, and I want to form as a table. Then we can use the pandas data frames, and we can represent the data in the form of tables. And another one is a SQL AIHME. Using this also we can show the data in the form of objects. Okay, that is, you can make your data as individual objects, and you can store the data into that objects. Next, for analyzing of data, generally whenever we want to analyze the data, we'll make a 5-number summary analyzation, or average, deviations, ratios, intervals, trends, and aggregations, and regressions, and clusterings. Okay, for making of this analyzation of data, so we can use different types of applications, like one is R and RStudio. This is related to the R language. So using this R language related tools, we can visualize the data, at the same time we can analyze the data, at the same time we can work with the different types of statistical analysis and probability analysis on the data. Next, for visualizing of data, so the general visualization models is like different charts, graphs, or maps, or dashboards. So for visualizing of this data, we have the different types of tools. So here one of the tool is called as a Plotly. So using this graphing library, we can visualize the data in a different effective ways. And another one is the Matplotlib. Using this also, this is a library of Python. So where we can plot the data in a different types of formats. Next is the Apache Superset. So using this Apache Superset also, we can visualize the data in a different graphs and in a different formats. And other important tools are the like Excel, where we can make a numerical analysis, and Tableau Public. Using this we can make effective dashboards. And other one is Grafana, is also used for the dashboard making, and Power BI is also especially for analysis and dashboard making. So these are all the different tools we can use to make different types of analysis plus dashboards and for visualization of the data. And especially the different challenges we will face within the data analysis is like poor quality of data. That is, sometimes we may not expect the highly qualified or highly important data will be given. And data privacy and security is very important. Whenever we are getting a data, we may not get the data sometimes, because for the security reasons they cannot share the data, and weak infrastructures, and data from the multiple sources, that is we cannot get a one particular source related data. We may have the different sources of a data, we need to be clubbed and we need to be combined and visualize it, and scaling of a data analysis. Okay, so these are the different challenges generally faced within the our data analytics. Okay, thank you so much for listening of this session. For any other information or for any other questions, you can reach out to us. Okay, thank you so much.